All right, so I just told you that the derivative and the integral, those are the same thing. They cancel each other out. So it says, use the fundamental theorem of calculus part 1 in order to find the derivative of the following functions. So here's what I do. G prime of x is equal to, I'm going to write integral 0 to t, and you're not going to write this out all the time. I'm sorry, it should be 0 to x, 0 to x, 0 to x, 0 to x. And notice to the left side, I wrote that derivative mark, correct? So to the right side, I'm also going to put that derivative mark. Derivative and integral are inverse operations. So they cancel each other out. And you are left with this guy. But substitute the x, square root of x plus 3. The variable. The next one, I take the derivative of both sides. So the derivative of the left and the derivative of the right. So g prime of x is equal to, anybody? Very good. So the dt and the integral thing go away. Now, the mistake that sometimes people make on the test is they're like, oh, well, I should use the product rule and find the derivative of that. That would be the second derivative if you were to do that. Okay? Derivative just makes those things go away. So if you were to actually do this, you would find an antiderivative, correct? And you would plug in x, and you'd get that thing. And then you would plug in 5, and you'd get a number. And what's the derivative of a number? Of a constant is 0. So that's why it goes away. It disappears. Good question. What do you notice is different about this one? Exactly. Take out your calculator so you can see what happens. Lower limit 0, upper limit 3. Are you guys used to this operation? I get 9. Watch what happens. We're going to switch it. I'm going to do second calculate. I'm going to choose number 7. And instead of entering 0 as the lower limit, I'm going to enter 3. And for the upper limit, I'm going to enter 0. Everybody agree that that is backwards? And as you do that backwards, watch what we get. What happens? It flips. So when we flip bounds for integrals, you can write this on the back side of your notes or somewhere. If we have an integral a to b of f of x dx, that's equal to the negative integral from b to a of f of x dx. So if you switch bounds of integration, it simply just makes the answer negative. You can actually integrate backwards, which is a crazy thing to think about. We don't quite have enough time to go into what that means analytically. You take an analysis course in college, you'll see that. But can everybody see you switch them, you make it negative? Okay, so let's go back to the problem. So equals negative integral 6 to x of sine of t squared dt. Everybody see how I switched it? Now, let's take the derivative. When I take the derivative, what are you going to get? Negative sine x squared. All good? That's all it is. This will be on your test. And by the way, when this is on the test, not everybody gets these right. So get them right, because these are supposed to be the easy ones. Next one I write as negative integral what? 3 to x of natural log of t dt. And I get that's it. What's different about this? There's a function, isn't there? Everybody agree that there's a function in a function? What rule did you use when you took the derivative of a function in a function? Chain rule, that's composition. It's exactly correct. You're going to be fine. You're going to be fine. You're going to be fine. Just watch it. This is the inside. Okay? This is the inside. 2x cubed. The outside, instead of using a variable of x, we use a variable of u. Integral from 1 to u of t over t squared minus 1 dt. What's the derivative of this guy right here? What do I plug in for t? I plug in u, so it's u over u squared minus 1. What's the derivative of this? 6x squared. So your final answer is to multiply those together. U is 2x cubed over, if I square that, I get 4x to the 6th. And I multiply that by 6x squared. So I have to plug u back in. And my final answer is 12x to the 5th over 4x to the 6th minus 1. We'll do one more, and then you have a half an hour to work on your assignment from yesterday. All right, let's see if you notice. What's the first thing you notice? Okay, the bottom, so they need to switch, don't they? So I switch that, and I get integral 2 to 1 minus 4x of cubed root of sine of t dt. Uh-oh, I have a function, not just x. And if I have a function, then I need to use the chain rule. So what is the inside of the chain rule? 1 minus 4x. What is the outside? Integral of from 2 to u of cubed root of sine of t dt. What is the derivative of this guy? Cubed root of sine of u. What's the derivative of that? Negative 4. All right, I dump that back in, so the end result is negative 4 cubed roots of sine of 1 minus 4x. All right, you got it. You should be smart.